Hello, here in this video, let's take a look at an example of how we can make a pulse, a high time, of a certain time, and we're going to use the timer interrupt to accomplish this. Well, one of the first things we can do here is we could say something like port B equals a 1, so we're going to make it high, and at some point later we're going to make it low. So this is the ending portion of it right there. Port B is equal to the low, so it's going to be high, it's going to be low, and we have to put a time in between. And we shouldn't forget too that we could do we'll need to do a DDRB, and this has to be set to a 0, 1 so that PB0 is an output for PB0, and I'm using PB0. I could change this to a base 2 number. It would look a little bit nicer if I do that. There we go. Well, next, let's turn on the timer at the fastest rate. That may or may not be appropriate for how much time you need, but if it's a short duration, the fastest time could be okay, possibly. And of course you can count slower if need be. So this is the fastest rate and the timer is on. Well, this is 1 microsecond per count. And I can count up to a maximum of 65,535. So we don't want to exceed, in this case, 65 milliseconds. Then I need to set the count, and I'm going to do this, TCNT1, that's the count, and it's going to be set to this number here. Well, what does this mean? We're going to start the timer X counts less than the maximum FFFF. When we go over FFFF on the timer, the interrupt occurs. And we want to come back lower than that by the amount X. X is going to be the amount, the time for the pulse. X equals time of pulse. So if X is a 2, we're going to be 2 less than the FF, and it'll be very, very short. It'll be 2 microseconds, but you know, whatever. Then after this, we sit here and we wait. And we wait by doing a while. And I'm going to say not done. Not done. So I'm going to sit here and wait until I'm going to wait until I am done. And done is going to be initialized to a false or 0. We said we were going to use the interrupt. Oh, I need to make this a variable, so I'll say int done. And I said we were going to use the timer interrupt, so we have to allow the timer interrupt. And you do this by saying this. SEI allows all interrupts, or I should say SEI is a global interrupt mask, and we're going to allow interrupts globally. Then after this we'll say time SK1 is equal to so what this line does is it allows the timer interrupt. Well, next we will need to put in the interrupt service routine. So I'll say ISR parentheses timer 1 underscore OVR there we go, OVF I should say, timer 1 overflow vector. It comes up automatically if you start typing it in correctly. And here I'll say done is now true. So when the interrupt comes through, done becomes a 1, and we go back to the wait on the while, and since the done becomes a true, we kick out of here and we go down to the next line, which makes the pulse a low. But I notice that the variable done needs to be a global variable because it's used in the subroutine, and we're not passing it into the subroutine. So I will come up here and I'll say int done, and I have to take away this declaration right here. It would be very bad if I left it. It wouldn't work, that is, because you'd have two different variables. So this is good, but it's not perfect yet because I need to put the word volatile in front of it. And what this does is it says to the compiler, don't make any assumptions on the value of done in this loop, because the compiler would assume that this is an infinite loop because the loop never changes the variable done. So the compiler would make it an infinite loop. Well, the compiler doesn't know that the loop will be interrupted and the done would be changed, so we have to tell the compiler that it's volatile and don't make any assumptions as to its value and don't take any shortcuts. The next thing that we need to remember to do is to include the AVR interrupts.h. Very important to do that. The next thing I need to address is x. X appears to be a variable, but you know what you can do? You could put in, let's say here, the actual number like 1,000, and that would be 1,000 microseconds. It is possible to turn that into a variable, but I think for us and for me right now, the easier thing to do is just to put an actual number in there. And it would be 1,000 microseconds. So I can put 1,000 microseconds. Well, there you have it. That is the program that should work well. And again, this program will make a pulse. And the time of the pulse will be determined by using the timer and the interrupt. The while loop here sits and waits until the timer overflows, and at which point it'll come back with a done value of a 1, and then we finish. So you could use this idea for other things besides just making a pulse. There's a lot of good things in here. One is a timer overflow vector. Another is a timer. We have showing how to use interrupts. So it's a pretty nice idea. And at this point we are finished.